طيب بسم الله الرحمن الرحيم. We'll continue. Yeah, finish this problem. Now we'll do this. I think this slide explain what we have in this section. We have for the infinite intervals, if the upper limit is infinity or the lower limit is minus infinity, then we just take the limit t goes to infinity, t goes to minus infinity. If upper and lower, we have the infinity, we have the infinite. So we'll divide it into two parts. As I said, now the problem, now this one will be B and this one will be A. Just we need to do the limit. So the problem will have two things, the integration and the limits. If you have upper endpoint, we have discontinuity in the upper endpoint in B. So you have the limit t goes to B from left, and I do the calculation. If the problem is in the lower endpoint in A, then I take t goes to A from right, and I do the integration, and then I'll find the limit, exists or does not exist. If I have interior point, then I like C, x equals C, I have discontinuity at x equals C. So I make the integral from A to C and from C to B, and then check them. By the way, in these two cases, in the last, in part C, in both types, if one of the integration diverge, that's it. The result, I mean, then the total integral will diverge. Okay. Determine whether each integral is convergent or divergent. Evaluate those that are convergent. Okay. So, as I said, usually it's two things. You need to think about two things: integration and limits. So, part the question number, this question limit. We have t goes to minus infinity. I have from t to 0, 2 to the power r dr. Now, as an integration, this is limit t goes to minus infinity. This is what? 2 to the power r over ln 2 from t to 0. That will be limit t goes to minus infinity of what? 2 to the power 0 is 1 over ln 2 minus 2 to the power t over ln 2. 2 to the power minus infinity, it's like e to the power minus infinity, that will be 0. So I have 1 over ln 2. 1 over ln 2, since this goes to 0. So I have convergent, and it's 1 over ln 2. 16, I have integral 0 to infinity. Sine theta equals sine theta d theta. As I said, it's now, first I need to take it, change it into limit. Limit t goes to infinity. 0 to t, sine theta equals sine theta d theta. First, I need to think of it as a integration. I need to have u and du. Here I can let u equal cosine theta. Du will be what? Minus sine theta d theta. So I need minus there and minus outside. So that will be minus limit t goes to infinity of what? Yeah, cosine 0, that will be 1. Cosine t. And I have what? EU du. That will be limit t goes to infinity with a minus sign outside. Minus 1. I have what? It's e to the power u from 1 to cosine t. That is minus limit t goes to infinity e to the power cosine. No. Yeah. E to the power cosine t minus e to the power 1 with the minus sign here. So e to the power cosine t This is what? As t goes to infinity. That will diverge. That will be diverges. Why? Because if we think about the limit as t goes to infinity of cosine t, this diverges. Why? This does not exist. This limit does not exist. Why? Because I don't know where I will stop. So it will oscillate. So I have e to the power something minus e. This is for sure it will not reach a specific value. So because of that, will be diverges. Okay. If you do this one, yeah, this 126. What I have? Integral 1 to infinity. I think we did this problem before, or something similar, or did the integral at least, just to save time. Yeah, it's this one. What was the integral? I think I did the integral on somewhere. That give me 2 tan inverse square root of x. I think I did the integral somewhere. No. Yeah. Yeah, the integral will be 2 tan inverse square root of x. 2 tan inverse square root of x. Okay. So I know that the integral tx is 2 tan inverse. Let's see. Okay. So I'll use this. So I have what limit? Write the problem. 1 to infinity dx over square root of x plus x square root of x. That will be limit t goes to infinity 1 to t dx over square root of x plus x square root of x. And I know that integral is what? 2 tan inverse square root of x from 1 to t. That will give me what? Limit t goes to infinity. Yeah. 2 tan inverse. There is a minus 9. No, minus. Where is it? Yeah, it's this one. We think 2 tan inverse square root of x. Yeah, from 1 to t. Square root of t minus 2 tan inverse of 1. Okay. So now what will be? I know that if t goes to infinity, then the square root of t goes to infinity. That implies square root of t will go to infinity. So tan inverse of square root of x or square root of t, tan inverse infinity, that go by over 2. So I have 2 times pi over 2 minus 2 times pi over 4. That give me what? Pi minus pi over 2, which is pi over 2. So it's convergence pi over 2. Okay. Next one. Let me try to squeeze it here. Integral 0 to 4 dx. Let me factor this one. That will be x minus 2 times x plus 1. Is it? Yes. So I have infinite discontinuity at x equal to. So we'll do this integral as what? 0 to 2 plus 2 to 4. And let us see what will happen. Let's do the first one. I need to do this integral. Yeah, sometimes it's good to do the integral. Tx over x minus 2 times x plus 1. That is what? A over x minus 2 plus b over x plus 1 dx. Now cover method, I think we'll do it. Cover, this is with 2. I have what? 1 over 3. Correct. This is with minus 1, so I have minus 1 over 3. I think that will do it. 1 over 3 plus over 3 is 1, yes. So I have 1 over 3 ln x minus 2 minus 1 over 3 ln x plus 1 plus c, and for sure I have 1 over 3 ln x minus 2 over x plus 1 plus c. Okay, so let me do this one now. Integral 0 to 2. Yeah, I'll try to squeeze it here. That will be limit x goes to 2. 2 from left. Yeah, dx over this. And that will be limit x goes to 2 from left. This one. This is from 0 t goes to 2. So I have 0 to t. This one will be t goes to 2. Yeah, any t. That will be 1 over 3 n x minus 2 over x plus 1 from 0 to t. From 0 to t. That gives me what? Limit t goes to 2 from left. 1 over 3 ln t minus 2 over t plus 1 minus 1 over 3 ln 2. Yeah, as t goes to 2 from left, this is will go to 0. Ln 0 will give me minus infinity. So this is will diverge. So this one divergent. No need to check the other one. Okay. Now we'll go to the old exam problems. Okay. Determine the value of this improper integral. E to the power x, I think we did some things. In one of the examples. Yeah. No, this is minus infinity to infinity. So I have 0 to infinity. Okay. Let me do it again, no problem. Yeah, sometimes it's to save time. I will squeeze the things. Okay. So now this one will be limit t goes to infinity. Integral 0 to t e to the power x over e to x plus 1 dx. If I let t equal e to the power x, then if I let u, then du will be ax dx. So that will be limit t goes to infinity, 0, e to the power t, du over 1 plus u square. That will be limit t goes to infinity, 0, yes, t goes to infinity, tan inverse of u from 0 to e to the power t. That will be limit t goes to infinity of what? Of tan inverse. Oh, sorry, this is not 0. This is e to the power t, that will be 1. Huh? I change this. E to the power t, that will be 1. So that will be 1. So that will be tan inverse e to the power t minus tan inverse of 1. Tan e to the power, if t goes to infinity, That implies e to the power t goes to infinity. That implies tan inverse e to the power t. That will go to pi over 2. So that will be pi over 2. Tan inverse of 1 pi over 4. So the answer is pi over 4. That is the answer. But I think that was when we have one of the exams were written. It had a written part. Okay. Now we have MCQ questions. This integral will do the same. Limit t goes to infinity 8 to t is minus x over 4 dx. Do the integration. Yeah, that will be what? Minus 1 over 4 e to the power minus x over 4 from 8 to t. Is it? Or minus 4, sorry. It should be minus 4. Yeah, differentiate this, you should get this, which is correct. So now this one will be limit t goes to infinity of minus 4 e minus t over 4 minus, be careful here, minus 4 e is minus 2 e over 4, which is 2. So I have limit t goes to infinity of minus 4 e minus t over 4. That will be plus 4 e is minus 2. That will go to 0. At t goes to infinity, this is goes to minus infinity. E to the power minus infinity goes to 0. So the answer is 4 e is minus 2. So it's converged to this. This improper integral, I need to solve it. I have limit t goes to minus infinity of this one. T goes to 0. X squared over 9 plus x to the power 6 dx. I need to do this integral. Yeah, now it's now a question of integration. Yeah. How to do this? One trick to do that, I will let u equal x cubed. So du will be 3x squared dx. So I need 3 and 1 over 3 outside. That gives me 1 over 3 du over 9 plus u squared. So this is tan inverse. So this is 1 over 3 times what? 1 over a, 1 over 3 tan inverse u over 3 plus c. So it's 1 over 3. So it's 1 over 9. Can make it 1 over 9 tan inverse x cubed over 3 plus c. Yeah, that will be the integration. So this one will be limit t goes to minus infinity of what? 1 over 9 tan inverse x cubed over 3 from t to 0. That will be limit t goes to minus infinity tan inverse of 0, which is 0 minus 1 over 9 tan inverse, minus tan inverse t cubed over 3. Now be careful. T goes to minus infinity. T cubed over 3 goes to minus infinity. So tan inverse of t cubed over 3 will go to minus pi over 2. So that will be, don't forget the 1 over 9. There is 1 over 9 outside here. That will be 1 over 9 minus times minus times pi over 2. And that will be pi over 18, which is this one. This improper integral. Okay. Where is the problem? The problem if sine equal 1, which is pi over 2. So if I have infinite discontinuity, at x equal pi over 2. Okay. And what is square root 1 minus sine square? This will be square root cosine square, and that will be absolute value of cosine x. But within 0 pi over 2, cosine is positive, so I have no problem. So that will be limit as t goes to pi over 2 from left, 0 to t, 1 over cosine, which is secant x dx. That will be limit t goes to pi over 2 from left, of ln secant x plus tan x from 0 to t. That gives me limit t goes to pi over 2 from left, ln secant t. I can make it sine and cosine. That will be what? 1 over cosine. That will be 1 plus sine t over cosine t. Do it at the same time. 0 tan 0 is 0. Secant 0 is 1. Ln 1 is 0. That's it. So now when I take pi over 2 here, I have what? This is will go to 1. Yeah, so I have infinity. So I have ln infinity, which is infinity, so it diverges. Yeah. This improper integral. I need to do the integration. I have problem at 2. I have infinite discontinuity. At x equal to, at t equal to. Yeah, use t. So I need to use another variable. Okay. So this one will be limit. Let me choose x. X goes to 2. From left, 0 to x, t over t minus 2 dt. How to do this integral? T over t minus 2 dt. There is a known trick. I have minus 2 plus 2 over t minus 2. That will be 1 plus 2 over t minus 2 dt. And that will be t plus 2 ln t minus 2 plus t. As I said, it's two problems. Integration and limits. So that will be limit x goes to 2 from left of what? This integral is what? T plus 2 ln t minus 2 from 0 to x. That will be limit x goes to 2 from left, x plus 2 ln x minus 2, 0 minus 2 ln 2. This one will be ln 0, which is minus infinity. So the answer is minus infinity, so it diverges. This improper integral. Yeah, very clear. I need to do some kind of calculation. Yeah, for finding the integral. The problem comes from where? I have no problem here. I have the problem only with the infinity. So I have limit t goes to infinity, 1 to t minus a minus square root of x over 2 square root of x, 1 plus a minus square root of x dx. Yeah, this integral, let me do it here. It's not a difficult one, but you need to be careful. I think there is a minus sign missing somewhere. Okay. Dx. So I will let u equal 1 plus e minus square root of x. Du will be what? Yeah, e minus square root of x times minus 1 over 2 square root of x. Yeah, good. There is nothing missing. That will be du. So it will be du over u. Yeah, nice. So that will be ln of u plus c, which is ln 1 plus e minus square root of x plus c. Yeah, now we get rid of the integral. Now we'll do the limit. I have what? This is ln 1 plus e minus square root of x from 1 to t. That will be limit t goes to infinity ln 1 plus e minus square root of t minus ln 1 plus e is minus 1. Okay, be careful now with the limit. Let me do it here. T goes to infinity. That implies minus square root of t goes to minus infinity. That implies e minus square root of t goes to 0. That implies 1 plus e minus square root of t goes to 1. That implies ln of that go to 0. So all of this goes to 0. So you have 0 minus this, which can be written ln of 1 over 1 to the power minus 1. And that will be that. So it converges to this. Yeah, this minus can go as a power. Okay. Yeah, I think we did this. 0 to 1. Oh, we did it 1 to infinity. We'll not do it 0 to 1. No, we did minus infinity to infinity. Now it's 0 to 1. Let me do it again. But yeah, we need to remember the integral is 2 tan inverse square root of x. No need to waste time. Do it again. 2 tan inverse square root of x. Integral is 2 tan inverse square root of x plus c. Okay, we have infinite discontinuity at x equals 0. So you have this is limit t goes to 0 from right, t to 1 dx over square root of x1 plus x, and that will be limit t goes to 0 from right of what? 2 tan inverse square root of x from t to 1. That will be 2 tan inverse, we keep the limit. That will be limit t goes to 0 from right, 2 tan inverse of 1 minus 2 tan inverse square root of t. If t goes to 0, I have tan inverse of 0 here. I have 2 pi over 4 minus 2 times 0. And that will be pi over 2. Let's converge to that. 1 over x ln x all cubed. Yeah. Very clear. Where is the problem? The problem just with the infinity. Okay. So I need limit t goes to infinity e to the power t 1 over x ln x cubed dx. So I need to deal with this integral, which is 1 over x ln x cubed dx. So I let u equal ln x, du will be dx over x. So that du, let me say u to the power minus 3 du, and that is what? Minus half u is minus 2 plus c, which is minus half ln x to the power minus 2 plus c. Okay, so this one will be limit t goes to infinity of what? Of, yeah, the integral is what? Minus half minus 1 over 2 ln x square from e to t. That will be limit t goes to infinity of what? Minus 1 over 2 ln t square minus 1 over 2 ln e square. So I have what? If t goes to infinity, then ln t goes to infinity. Then ln t square goes to infinity, but 1 over ln t all squared, that goes to 0. So I have here 0, but here I have what? 1 over 2 ln e, so it's 1 over 2. Ln e is 1 squared, that will be. Just 16 tan inverse 1 plus x squared from 0 to infinity. I have problem just with the infinity. 0 is okay. I have no problem here. Okay, tan inverse is defined everywhere. I have no problem. Okay, so I have what? Limit t goes to infinity, 0 to t, 16 tan inverse x over 1 plus x squared dx. So let me do this integration. Yeah. If I let u equal tan inverse x, what will be du? Du is equal dx over 1 plus x squared. So that will be 16 du over u du. Yeah. Yeah, 16 u du. So that will be what? 8 u squared plus c, which is 8 tan inverse x plus c squared. Okay. Now let me do the calculation. T goes to infinity of what? This integral is 8 tan inverse x all square from 0 to t. That will be limit t goes to infinity 8 tan inverse of t square minus 0. That's it. So note, if t goes to infinity, be careful here. Tan inverse of t will go to it pi over 2. So that give me what? 8 times pi over 2 all square. That will be 8 times pi square over 4. That will be 2 pi square. And that's the answer. Here we have problem at 0. Yeah. So I have infinite discontinuity at x equals 0. Let me do the calculation. That will be what? That will be this integral. Actually, I split it -1 to 0, dx over plus 0 to 4, dx over this. Okay. Let me do the first one. This one, -1 to 0, dx over square root absolute value of x. Yeah, be careful. From -1 to 0, this will be minus. So that will be -1 to 0, dx square root of minus x. Okay. Now this will be limit t goes to 0 from left. Yeah. -1 to t dx over square root minus x. Let me write it minus x to the power half dx over minus half. Sorry. Yeah, that will be what? Be careful. Limit t goes to 0 from left of what? Is you add 1, that will be half. What is minus x? minus x, you need to be careful. You need a minus sign. So if I let me do this integral especially to be sure I did not do any mistake. So let u equal minus x, du will be minus dx. So I need minus and minus. That will be minus u to the power minus half du. That will be minus. You add 1 half to u to the power half plus c. So this will be minus 2, where u is minus x. Huh? So this will be minus 2 minus x to the power half plus c. Okay. So it's minus 2 minus x to the power half from minus 1 to t. That gives me what? With the t, I'm having minus 2 minus t to the power half minus. That will be plus 2 minus x minus, that will be plus 2. Then get the limit. So this will be 0, so the answer is 2. This is 2. Is it? Yeah. Now let me do the other one. Integral from 0 to 4 dx over square root absolute value of x. Now this will be positive. So you have 0 to 4 dx over square root of x. Okay, which is limit t goes to 0 from right, t to 4, x is minus half dx. Oops. And that will be equal to what? Limit t goes to 0 from right of what? What is the integral of this? It's 2x to the power half from t to 4. That will be limit t goes to 0 from right. 4 square root of 4 is 2. That will be 4 minus 2 t to the power. T goes to 0. That will be 0. So the answer is 4. So this one will be 2 plus 4, which is 6 convergent, and it's equal to 6. Calculation. Now, as I said, the problems becomes integration and limit. That's it. And most of the problems which we did, mostly we have just calculation of integration mainly. Limit are easy ones, but you need to be careful about tan inverse, these things. This improper integral. Yeah. Where is the problem? The problem just with the one. Here I have a problem. So I have infinite discontinuity at x equal 1. So that will be limit t goes to 1 from left, 0 to t, cosine inverse x over square root 1 minus x squared dx. Okay. Now let me deal with this integration. Let's see what square root 1 minus x squared dx. So I let u to be cosine inverse x. Du will be what? Minus 1 over square root 1 minus x squared. So I need minus minus. That will be minus u du. Integral. Yeah, this is du with the minus sign. Yes, I have minus u du. That will be minus u squared over 2, which is minus cosine inverse x squared over 2. That will be which, okay. So that will be limit t goes to 1 from left of what? Of minus cosine inverse x squared over 2 from 0 to t. Yeah, that give me what? That will be limit t goes to 1 from left of minus cosine inverse t square over 2 minus cosine inverse of 0, it will be pi over 2. So that will be minus pi over 2 square over 2. Now, cosine inverse of 1, that will be 0. So all of this will be 0. 0 over 2, which is 0. And I have plus pi square over 8. Over 4 over 2, that will be pi. It's equal to this. E to the power x sine x. Yeah. We need to, the problem just with the infinity. So I have limit t goes to infinity, 0 to t, e minus x sine x dx. Yeah, this integral is a complicated one. Let me do it here. E minus x sine x dx. I need integration by part 2 times. Yeah, I didn't notice the point here. U equal what, sine x, du equal cosine, dv equal e minus x dx. So b is b minus x dx. Okay. Call this I, because I need to return back to this I. I will be what? Is minus x sine x minus integral. That will be plus minus is minus x cosine x dx. I need to repeat this again. U equal cosine x. Du equal minus sine x dx. dv equal is minus x. And v equal minus is minus x dx. Here I have dx. What is this? This is dx. So I will be what? Minus is minus x sine x. Minus is minus x cosine x. Plus minus plus, that will be minus a minus x sine x dx, which is I. So I have 2i, take it another side, that 2i will be equal minus is minus x sine x minus is minus x cosine x. So I will be this over 2. So now this integral, this limit will be limit t goes to infinity. Of what? Minus is minus x sine x minus is minus x cosine x over 2 from 0 to t. That will be limit t goes to infinity. Minus is minus t sine t minus is minus t cosine t over 2 minus sine 0 is 0, but cosine 0 is 1. That will be minus 1 over 2. Yeah, I need to find this limit. Let me do it here. Limit t goes to infinity. E minus t times sine t plus cosine t. How to find this limit? It is 0. Why? Why it is 0? Yeah, I can use the what? I think one way to do it through the squeeze theorem to prove this is 0. Let me do this limit and prove it's 0. Limit t goes to infinity is minus t sine t. Yeah, use the squeeze. This is 0. Why? Because sine t is between -1 and 1. That implies multiply by is minus t. Now, as t goes to infinity, this goes to 0. And this one also goes to 0. So this goes to 0. And the same for cosine. Do the same for cosine. So this will be 0. Which is very clear argument there. So the answer is half. Do the same for cosine. Is minus t. For limit t goes to infinity, is minus t cosine t is equal to 0. So 0 plus 0. So that will be half. Yeah, I need to deal with the limit somehow. Okay. Let me do this one, then I will stop. I have a problem with the 2. I have infinite discontinuity. At x equal to. That will be what? Limit t goes to 2 from right, t to 4, dx over x minus 2 square. Well, let me write it. X minus 2 to the power minus 2 dx. That's an easy integral. This is linear, coefficient of x is 1. So that will be x minus 2 to the power minus 1 with the minus sign. Yeah, from t to 4. Am I right? Yeah, differentiate, you should get this one. So I have the limit as t goes to 2 from right of what? Minus 1 over 2 plus 1 over t minus 2. This limit will diverge. Actually, it will go to infinity. It will go to plus infinity. So it will diverges. Yeah. Yeah, let me stop. I think I'll stop the recording. And then I will continue doing some more problems. Yeah, thank you.